The objectives in this lesson is to factor a sum and difference of cubes. A sum and difference of cubes. So here are your perfect roots, at least the first 5 of them. I would highly suggest that you get to know. It will certainly make it a lot easier when you are factoring a sum and difference of cubes, or at least make sure you have your calculator handy. Now, as far as the variables, you can also have perfect cube root variables. If your variables are raised to the 3rd power underneath the radical symbol, and you also have a 3 outside, then they are perfect cube roots, which means they will equal whatever the variable is. So that's just some FY information you'll need to know when solving problems involving sum and difference of cubes. Here's a helpful hint when factoring a sum or difference of cubes. They will always factor into a binomial and a trinomial. In terms of what goes inside the binomial and trinomial, it's going to look like so. So, what goes inside A, then B, A squared, A and B multiplied together, and then B squared. In fact, when I taught this in class, I would always have my students chant with me a little chant to help you remember it. So by the time of the test, you have that embedded in your brain and it'll help you remember it. So yes, it may seem a little silly or weird, but I'm so okay with being weird as long as my students can learn in the process. So it goes a little bit something like this. I'm going to chant it 3 times. A, then B, A squared, A and B together, B squared. Again, A, B, A squared, A and B together, B squared. One more time. This time you do it with me. A, then B, A squared, A and B together, B squared. And there you have it now. Okay, let's continue. How about the signs? Well, with the signs, all you have to remember is the acronym SOP. SOP stands for same, opposite, positive. So for example, if you have a sum of squares, your first sign will be the same as your original problem or your original sum of cubes. The next sign will be the opposite of what the original sum of cube is. And the last sign will always be positive. So again, in a sum of cubes, your signs are SOP, same, opposite, positive. So that is how you fill in the signs with your binomial and your trinomial. And if you have a difference of cubes, it is still the same thing. Your signs will be SOP, same, opposite, positive. So the first sign, the one that's in the binomial, will be the same as your difference of cube you were given. Your next sign will be the opposite, and your last sign will always be positive. So that's how you can remember. Just remember the chant in terms of what goes inside the binomial and the trinomial. In terms of what signs goes inside the binomial and trinomial, it is always SOP. And there you have it, helpful hints for factoring a sum and difference of cubes. Okay, let's do some problems factoring a sum and difference of cubes. So step one, I would suggest, is identify what your signs are going to be so you don't have to focus on the signs once you start filling in the binomial and the trinomial. So remember the signs are SOP, same, opposite, positive. So we are given here a sum of cubes, and we know it's a sum of cubes because you have two perfect cube root numbers with a plus sign between them. So because this is a plus, uh, in terms of our signs, the binomial and the trinomial, it's the first sign is going to be the same as this. The second sign is going to be the opposite, which is a negative. And remember, the last sign is always, always positive. So the signs in the first example are going to be a plus, negative, plus. So now that we know that, we're not going to focus on sign. Let's focus on what is actually going to go in the binomial and trinomial. And remember the chant, A, then B, A squared, A and B together, B squared. So the first term, we call that A. So you have to find the cube root of that, and recall the cube root of any squared term is just going to equal that variable. So the cube root of x to the third power equals x. The cube root of 8 equals 2. So again, remember, if you don't have your cube roots in memory, make sure you have your calculator handy because you'll need that information. So now that we have the cube root of those, the actual numbers, that's what we're going to be dealing with here, is an x and a 2. We're going to call x A. We're going to call 2 B. So let's fill in the binomial first, which is A, then B. So what that will be x and then plus 2, because B is 2. Now we have the binomial. Let's go to the trinomial. Remember, it's going to be A squared, A and B together, B squared. So let's do the A squared. If A is x and we square that, we get x squared. Multiplying A and B together, you're multiplying 2 times x, which is 2x. And again, we're not focusing on the signs. We already have identified those. Last is B squared. If B is 2 and we square that, we get 4. And there you have it. You've just factored a sum of cubes. Now let's do the next example. I see two perfect cubes here with a minus sign between them, so that is a difference of cubes. So first, let's identify the signs. For the given difference of cube, we have, it starts with a negative. So my binomial will be the same as that, a negative. So my signs will be negative, then the opposite of negative, positive, and then the last term always positive. So my signs will be a negative, positive, positive once I plug them in. Now let's forget about our signs for a moment and focus on the actual terms that go inside the binomial and trinomial. So first I want to find the cube root of p to the third power. So the cube root of p to the third power is p. The cube root of 27 is 3. So those are the two terms I'm going to be dealing with, p and 3. We're going to call A p. Let's call B 3. So remember the chant, A, then B, A squared, A and B together, B squared. So let's get A and B. A and B would be P and 3. It's going to have the same sign as the given, so it's going to be P minus 3. Next, I want to do A squared. If A is P and we square that, we have p squared. Next, multiplying a and b together, and that's going to give us 3p. Next, square b. If b is 3 is, and we square that, we get 9. And there you have it. We have just factored a sum and difference of cubes. So let's do a little practice to make sure that you understand what you're doing. So here we have the first example here, a difference of cube. So remember, you're going to have to find the cube root of those terms. The cube root of y to the third power is y. The cube root of 64z to the third power equals 4z. So those are the two numbers you're going to be dealing with, y and 4z. So now you're going to plug those in. But first, make sure you identify what are the signs. Once you identify the signs, go ahead and plug in all the values. And what you should have, if you did it correct, is the following: y minus 4z times y squared plus 4yz plus 16z squared. Try the other one. So step 1, identify what your signs are going to be for that sum of cubes. Then find the square root of the first and last term. The square root of 27k to the third power is 3k. The cube root of 8 is 2. So those are the two terms that you're going to be dealing with. And then you're just going to simply go ahead and plug them into your binomial and trinomial, keeping in mind with a, then b, a squared, a and b together, b squared. So if you did that correct, you should have the following. And there you have a sum and difference of cubes. In these last two examples, I want to show you that sometimes you may have two terms that share a GCF. So you must first take the GCF out. That is always step 1 when you're doing any type of factoring. So you want to look inside both terms to see what is it that they share in common. The best way to do it is to start with the smallest number. In this case, it's a 5. And then you ask yourself, is there a 5 inside 40? And yes, there is, because 5 times 8 is 40. Now, they both do not share an m in common, so the GCF would just be 5. So GCF on the outside, and whatever is left goes in parentheses. Next, we notice here we have a difference of cubes. So we're going to go ahead and factor that difference of cubes. And there you have it with your answer, GCF on the outside. And what's left is the factorization of your difference of cubes. Go ahead and try the next example. Find the GCF. And then what you should be left with is a sum or difference of cubes, and then you're going to factor it further. So what is the GCF of those two terms? If you said 6, that is correct. So now go ahead and proceed with factoring the sum of cubes. So if you factored it correctly, again, you should have the factored form of the sum of cubes with the GCF on the outside. And there you have it, a sum and difference of cube with first taking out the GCF. Okay, that's it for this lesson. Thank you for watching MVP Tutorials by your instructor, Dr. Speights. I hope you'll join me in the next lesson. Please feel free to like, share, and subscribe. Goodbye for now.